All right, now for page 4, we got number 10 here. The current in a simple electric circuit is inversely proportional to the resistance. If the current is 80 amps when the resistance is 30 ohms, find the current when the resistance is 12 ohms. Now, this is very, very tempting to want to set up like a proportion, but you don't because of these words right here. Inversely proportional. Another way they say that, remember, is that it varies inversely. So anytime you see that inversely, you can't use a proportion to set these up. So don't do it. Now, how do you set it up? Well, remember, if it varies inversely, if it varies directly, then it is a proportion. So, you set one over the other, you divide those pieces and divide on the other side. So you have that fraction equals a fraction. But when it's inversely, you have to multiply those pieces. So you're not dividing, you're multiplying. So these two pieces go together, so we're going to multiply those together. So 80 times 30 is one side of our equation. Find the current when the resistance is 12 ohms, so we don't know what it is, so that's going to be X times 12. And that's it. That's your equation. So now we just got to simplify it and solve it. So if we multiply those, we get 2400 equals 12x. So let's divide that by 12. And so x equals 200. Nice and quick. Don't forget your units though. So 200 watt. So, well, let's go back and look. A current of 80 amps when the resistance is 30 ohms. Find the current. So again, current, so amps. Amps is going to have to be our units. Don't forget those units. All right, so that kind of wraps up some of those word problems. So now we got some exponential stuff. Now a lot of these are going to be fairly quick, but be careful. It's easy to make mistakes too. So we got 4 over 3, and we got the whole quantity squared. So now remember, you can apply the power rule to this and basically distribute that exponent onto both the top and the bottom. So we got 4 to the second over 3 to the second. So that would just be 16 over 9. Now it doesn't say anything about writing it as a mixed number, so you should be fine to leave it as an improper fraction. But again, read the directions, especially in the My Math Lab. They're very picky, you know. So, but that is going to be your answer. So what about this one? Well, it's very, very tempting to want to combine these negatives together, but you don't. You got to take care of the exponent first. A negative out in front is kind of like subtraction. So subtraction comes after exponents do. So we want to make sure we apply that exponent to what's in the parentheses first. So my LEDs are not cooperating. I'll see if I can squeeze this one out. So if we wanted to do this, this is technically equal to negative of negative 2 times 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 negative 2. 1, 2, 3, 4, 5, 6. So we had 6 of those. All right. So what's that going to be equal to? Well, we still got this negative out in front. We got 2 of them are going to combine, 2 of them are going to combine, 2 of them are going to combine. So there's no more negatives. All those negatives will cancel each other out. So we should be left with a negative 64 when we multiply it all out. Now number 13, though, has got a negative exponent. Well, let's first get rid of the parentheses, just like we did up with number 11. If we distribute that exponent onto the top and the bottom, we have that. So what's the rule say about negative exponents? How do we take care of those? Remember, it's kind of that ziggy-zaggy, flippy-floppy type of process. So remember, when it's negative on the top, we can fold it down into the bottom. And when it's negative on the bottom, we can fold it up to the top. So, and the only thing that changes is that the negative exponent changes to a positive exponent. So we end up with 4 to the third over 3 to the third, which we can do. Much, much easier. So this is going to be 64, and this is going to be 27. Again, it's improper, but that's okay. If they don't specify, then you're good. All right, one more of these, and that will wrap up this page. So we got, some 0 exponents. But we got parentheses on the one, and we don't have parentheses on the other one. So we can't treat these exactly the same. One of these is going to be 1, and one of them is not. Which one of these is equal to 1? Well, because the parentheses are encapsulating that negative sign, this whole thing is raised to the 0 power, so this is equal to 1. The other one is equal to negative 1, because you have to treat that negative after you apply the exponent, because it's like subtraction. So 5 to the 0 is 1, but the negative makes it negative 1. So negative 1 plus 1 is 0. So that was a quick one, but easy to make a mistake on too, so be careful. All right, let's stop here, and we'll pick up the last page in the last video. Stay tuned.